Hello, this is my talk for the NehamCon Europe 2022. I'll speak about an RCE I found on Apple using Hotjar swapping. First of all, I'll speak about some prior research to this, then I'll speak about the flows I'm trying to abuse and the assumptions I had while doing that. I'll share some demo code for you on GitHub as well, and I have some conclusions that I think you might enjoy. My name is Frans Rosén. I work as a security advisor at Detectify. I celebrate 10 years as a bug hunter this year. Woohoo! I'll speak about Hotjar swapping, and you might not have heard of it before, and it's basically made up, but if you Google it, you will see some clues around what I'm trying to abuse here. And the prior research to this is mainly around hacking Apple. And if you want to hack Apple, there's one tip I have for you, and that's reading one of the most epic blog posts there is. And that's the We Hacked Apple for 3 months, made not only by the creator of this conference, but also Sam Curry, Brett Bauerhaus, Samuel Erb, and Tanner Barnes. And I totally recommend it because it contains so many different bugs, so much information about how to approach Apple, how to actually find bugs there. And one of the bugs that caught my interest was around something called an authors e-publisher. It's basically a website called authors.apple.com, which allows you to upload EPUB files. And while doing this, Brett actually found a command injection by just providing a different ID to the ones uploading. So he was able to escape the arguments in the command that was made into this app. What's interesting about this app is that you can actually download the same app that runs on authors.apple.com. You can download it and run locally as well. And if you run it locally, you will quickly see that it's just a wrapper to Java. It uses basically the transporter launcher, an ITMS transporter launcher. And a disclaimer to this is that I suck at Java. I completely suck at Java. I'm not a Java developer at all. However, I do love something called GDGUI, which is a Java decompiler user interface for figuring out how code in jar files and wars, how they actually work. So I totally recommend this. Even though I'm not a Java developer, I can read Java code and understand it. So first of all, when looking at the Java ITMS transporter launcher, you could see that the first thing it does is downloading an OSCI bootstrapper. And basically it's also checking the SHA-256 and the MD5 of this jar file, making sure that it has the up-to-date version of it. And if it doesn't, it will download a new version. You could also see that it downloads it to a different directory depending on if you're running on Mac OS or Linux, for example. So the first step in the flow is that check the MD5 and SHA-256 of the OSCI bootstrapper in a specific directory depending on the operative system that you're running. And if it's not matching the remote values of the MD5 and the SHA-256, you will download a new version. Now, the next step of this transporter is that you will upload an ITMSP file. ITMSP is basically a pre-generated store package for the iTunes store. And an ITMSP package is, if you read around it, basically just a zip file with a metadata XML together with, for example, an EPUB file, uploading an ebook. And the manifest contains the files, the size of the files, and the MDFM, making sure that all the files exists, making also sure that the files are not corrupted in any way. So you can see that the files in the ITMSP is actually matching the values in the manifest. Now, what we can conclude now from the flow is that we have the EPUB and the manifest in the zip. It contains the MD5. Everything needs to match for it to work. The next step is that it's actually extracting the EPUB file locally. Before uploading it to Apple servers, you're actually extracting, if you're running this command locally, it will extract the zip file and then go through the EPUB file basically and validate it and making sure that everything is as it expects it to be using a validation tool. So we know now that the EPUB toolkit will extract the zip file before uploading it to Apple servers. Now, the additional flow, not running the transporter app locally, but running it remotely, if you're uploading an EPUB file on the authors.apple.com, This one will basically wrap your EPUB file in with a manifest, making its own ITMSP file, and then running the transporter code on their server instead. So when you start looking at the requests made when you're uploading an EPUB file, you will see that it's actually making a ITMSP file itself. And what's interesting also is that now we know that it's running the same kind of application, both locally where you can download it, and remotely where you can just upload files to make it process them. So this also means that if we find a vulnerability, we can trigger it also remotely on Apple servers. So this is the way you run the ITMS transporter locally. It has a bunch of commands. This is the upload one. You're basically referring to an ITMSP file, and you're also referring to who you are and the user and password. When you run this remotely on Apple servers, they will pre-fill a bunch of things here. And remember, they are the ones creating the ITMSP file. So the zip file for the ITMSP, you cannot upload the ITMSP directly to Apple servers. That one is created by their own, by wrapping the EPUB file basically. But we have a bunch of things here, so let's exploit this. We know that the EPUB file is a zip file. We know that there's an XML manifest, etc. Let's try to see if we can find some ways in here. And the thing with zip files is path traversal. You're basically able to pack ... paths into a zip file, basically meaning that if you're unzipping a zip file without a code that's actually protecting you from path traversing, you can basically extract things outside of the directory that it was pointing to, because you have ... in the file names. So this is was actually one of the first things I tried when doing this, was that I will make an evil EPUB that's a zip file with path traversed variables in it, or path traversed files. So I created a text file. I used the evil zip, which is basically just a wrapper to creating a zip file, and used ... and then a directory that doesn't exist with a file. And what's interesting then is that if this actually works, just because this directory I referred to, temp z, because that doesn't exist, a regular zip extract will actually fail, because it says that there's no such file or directory that exists here. So this is a kind of a good trick for testing path traversals, is to point to a directory and then a file into that directory where you know that the directory doesn't exist, because the zip file extractor won't create directories by itself, especially not recursive directories. However, when you get this error, you can then try with TMP, like the temp directory is something that mostly exists for everyone. And when I did this, I actually got no error. Then it actually worked perfectly. So this means we can write to temp, and we can do a path traverse using the EPUB zip. Now, there's different temp files and temp directories used from the transporter app, depending on if you're running on Mac OS or Linux. And locally I'm running on Mac OS, so whenever I tried things, I had to make like a symlink locally to actually simulate what would happen if it was on Linux. And this is the reason why I did that, was when you're uploading into the author's Apple, you will see that it's actually running on Linux. Also, you will see that the directory that they're using to download the settings of the OSCI the OSCI bootstrapper and all these things, it's actually running inside the TMP folder, which is exactly what we can write to when we're trying to upload files to authors. And this place was where I spent most of my time. This is basically like, how can I exploit this? I know I can write files outside of the expected temp directory for the ebook. I know I can write files outside of it, but what should I overwrite? And what can I overwrite? What can I do to, trigger code or trigger a cron tab or whatever? So there's 2 days of attempts trying to figure out exactly what type of rights I have overwriting certain things. And it became a bit of a struggle, actually. And I had some conclusions after these 2 days that I tried to summarize. Basically, there's no way for me to run, crons or anything. That wasn't possible. However, I could write to temp. And we know the app using the output of the author's Apple, the bug log that you get back. We know that they're running, they're downloading the OSCI bootstrapper, and they have the properties and the settings. They have everything in the temp file. Also, I kind of figure out that the server that hosts this is only running Java mainly. Like, that's what it's there for. It's basically triggering this transporter flow to upload this file in the proper sense up to Apple's iTunes store. And what we also know is that the flow happening when the OSCI bootstrapper and everything is downloaded, all those things are happening before our zip is even touched. So if they have loaded this jar file into memory, we have no way of, triggering it another time at all, because it's already loaded into memory. And I tried doing this locally and I couldn't make it work. Now, there was one interesting discovery while doing this. And the interesting discovery is basically when I tried to replace the OSCI bootstrapper, which we knew the location of because we saw it in the logs. It was temp.itms_transporter/lib/OSCI bootstrapper. Whenever I overwritten it with something, whenever that happened, whenever as soon as the flow of uploading a file was done, and this was happening locally, as soon as it was done uploading, it would crash with a class not found exception. And I wrote to my friends, I actually, this was Brett and Matthias of Lidimbrunn, basically. I wrote to them late evening after 2 days of spending the time with this. I wrote to them like, okay, I got it to crash. This must mean something, right? I have a class not found. It's basically happening something with the jar file that is causing it to actually crash. This must mean something. So this class not found was very interesting, and it created an idea in my head. The idea is, let's mimic the OSCI bootstrapper, because it said class not found, right? So let's decompile the .class in OSCI bootstrapper, one of the classes, modify it, then compile that one into a class file again, then combine that class file and repack it into a jar file, the same OSCI bootstrapper but a bit different. Then put the jar in the EPUB to replace .temp ./temp ITMS transporter lib OSCI bootstrapper, basically getting it to find the class again, just because the thing I replaced it with now didn't have the class in it. So what I did is basically I had an original directory with all the .classes, and then I had a transporter with the Java files, so I could compile the Java files and move them into the class files to repack the jar properly after that. And then I made like a Java compile and copying it over to the original just to be able to create this kind of jar file using the same kind of method that it looked like before. Also, I then pointed it in the evil zip to actually use this jar file. So this is the one I'm replacing the OSCI bootstrapper with. And I tried this out. What happened was a zip file invalid lock header, bad signature. That was basically the result of this. And I started Googling, and it says like, if you have multiple classes loaded of one jar file, but you have different instances of URL class loader, and you change this jar file at runtime, you will get an error. The zip file invalid lock header, bad signature. The error might be different, but I'm like, okay, this is an expected error that happens if you change a jar file using runtime, especially if you're using the URL class loader. And I was like, okay, this took me an hour to actually spend time with this. I came a bit further, but I kind of realized like this, I'm probably screwed, right? I'm foiled again, right? But then I thought to myself, like, what does lock file, what does lock header mean? What does, failed signature? Does it actually have a signature check on the, the parts of the jar file? Like, how advanced is this? So I started looking at the actual, documentation around these errors. So what I could see is basically this function. This function is the one triggering the zip file invalid lock header error. And what you can see here is that basically it's using the zip file as is, and then using offsets to read the things that it wants to extract from the jar file. to be able to unpack it. But then it's actually checking a header of this and comparing the header between what it had, unpacked before and after, just to figure out if this works. So I was scared that what it's actually doing here is looking for a signature around, CRC32 or some form of real sig check here. That made me really scary, because this is actually the validation here that it does. And this happened 2 hours after the fact that I kind of realized that I was being, this wasn't possible. So we have a bunch of things to play with. And if you unzip with LV as arguments, you can basically see a bunch of parameters, not only the things that you've packed in the zip file. A jar file is a zip file, right? You could also see the original length of the files. You could see the compression rate. You could also see the size they end up with after the fact that they've been compressed. In addition to that, you're also seeing the CRC32, basically. So when I saw this, I was kind of worried that the CRC32 had to be, validated against the class files, which meant that as soon as I replaced a class file, it wouldn't work at all. And remember the error that we saw. We saw class not found exception, and we saw bootstrap util, but we also saw a $sign and then a 1. And when we look in the jar file, we actually have two .class files for one of the classes that we have. The bootstrap util actually have two classes in it, which is kind of interesting, right? So I started looking at this as what is the $1.class? And someone wrote, I think it was on Stack Overflow, they said that inner classes in a class inside a jar file will actually break out into its own class file, because the inner function is its own kind of anonymous class inside it, and it will still break it out. But what's interesting with the inner classes is this was the one triggering this error. This basically meant that even though the OSCI bootstrapper was loaded, the $1 class was still, getting triggered and failed because I replaced the jar. That was something that was extremely interesting here. And when I looked at the bootstrap util class function, I could find the inner class being this simple file visitor. It's basically a callback for walking through a directory. And this basically allows you to recursively delete a directory containing a bunch of files. So when I saw this, I came to the conclusion that, okay, there's something actually reading the jar file again, even though the jar file is loaded, and it has something to do with these inner classes. And maybe we can do something in our replacement jar that can make sure that it believes that this is the same kind of code. So we're changing our idea a bit. We're decompiling the class into OSCI bootstrapper. We modify the inner class, not the outer class or the regular classes, but the inner class, and then compile it into the class. We make sure the size and the compression is the same. Those things are variables that we can control because, it's only a matter of length and size, and making sure that the compression rate stays the same. Then we repack it to a jar file. We put the jar in an EPUB and try to replace it. Here's a guy with a horse. So cue the A. Basically, what I did here is that the zip files of a jar is using deflate. Deflate compression is basically a very, very basic algorithm of trying to, find patterns that you can repeat and then trying to shorten it down. This is my guess, right? I don't exactly know how it works. But the end result is basically that, 5ace compresses more than ADAF, for example, because you can say that it's repeating multiple times. And this allows us to iterate whenever we want to match the compression rate and the size before and after. We can actually utilize the fact that it's compressing, consecutive letters and non-consecutive letters differently. This helps us into figuring out if we can, get the compression rate the same. And we will actually try to exploit this using system out print, which allows us to, get an output. And because we're getting the log, we're basically getting the output directly, and we're able to see directly if we get it to work. So my first attempt was basically to write some code to not, as you saw with the walk file tree, the only thing that they did was basically deleting files. So we had a certain limit of how much code that was needed for everything that was happening in this inner class. So and I started doing, replacing also, I had the exact same length left, and then try to get some form of data out as well. In this case, the path directory or the path environment variable, just to have something that could actually work. So then I started, making a comparison, and my first attempt when I had, the same kind of length from the beginning, and I tried it with just but then, tried to echo the path out. I could see that, the 1649 that we see here is the same. So the original length is exactly the same as before. But remember, this is not the length of the Java file. This is the length of the compiled result of the Java file. So this doesn't look, this AAA looks really long, but that's because the original file delete was actually creating a bunch of code in the compiled class file. So what we could see here, however, is that it's compressing too much. It's returning it into 645 instead of 647. So we need to make it a little bit worse at compressing the worse at compressing the file, because it's making a too good job for it. What happens then when we just insert an F somewhere is that basically now it's compressing too little, because now you've put a letter in there that prevents it from compressing it as good as possible. I made a video of me, trying to figure this out locally. So I'm like running, changing letter. And I came to the end when trying this locally that, okay, what happens here is that if I put two Fs in the beginning, I maintain the same kind of length. I put two Fs in the beginning, I end up with 1649 in the beginning, and afterwards 647. And 2 hours after I came to this realization, I run the EPUB file, I upload the ITMSP locally, I run it locally, and I see that I get, all these A's out. And I realize, okay, I've spent, first of all, I realized it in 2 a.m. But then 9 a.m. I was able, so I spent a huge amount of time during this night just to trying to figure it out. So basically when I then uploaded this to the authors.apple.com, I basically saw the path file. This was actually working. I was actually triggering this flow just by making sure that the compression rate and the size before and after was actually the right. So just hit an email to Apple reporting this RCE. This is a remote code execution on authors.apple.com using the fact that we can replace the jar file with inner classes if they have the same compression rate and length. And I wrote to them also, like, this is one of probably top 1 best bug I've ever found, because it took so much time to figure it out, but also it was so amazing to actually find, this way forward. And I wrote to Brett and Matthias and okay, I was actually able to exploit this to run the command. In this case, I'm running, an open connection to an external server. But then I was also able to get the runtime and execute a curl command using whoami just to figure out who the user is, the app user. What happens when I reported this to Apple and when I was able to actually run my code on their servers was that the code I was sharing with them, I shared on iCloud, and suddenly I had a bunch of people just showing up, sharing this code internally on Apple. And one day after, they basically shut down the EPUB, the author.apple.com, because they realized that we need to figure this out before, anything else happens. I also have an obligatory, Matthias' reaction, which after I wrote this, you know, day and night trying to explain to them how I actually did this, he was like, okay, this is pretty good. And the demo here, what I've actually done in the demo is I've created a simple app. It has 2 bash files. One is called build and run. Build and run will load in an external jar file from a bootstrapper, and then it will wait for you to click enter. And basically what happens on enter is that it will invoke a method for one of the already loaded classes in the jar. That's basically what happens. And then we have a bash file called exploit. And the exploit will basically replace one jar file with another and run completely different code that was loaded from the start. And I will show you a video of this. Basically, I will run the build and run. It will tell us that I've compiled everything, I've loaded the jar right now, and this is how it looks like correctly. And then we have a malicious secondary Java class, which has a replaced code. So we will open up a new tab. We'll wait here and open up a new tab, run exploit. We will see that there's no diff in the compression. So when I run now, my replaced code will run. Even though the jar file is actually loaded, I will still be able to replace things and run different code in the jar. So my conclusions to this is that this is absolutely exploitable elsewhere. This has nothing to do with Apple in specific. This is also like primarily because of URL class loader. There's no OSCI needed. There's no, you know, it's only the URL class loader that behaves like this. And the class needs to have inner classes for you to actually replace them. You can't introduce inner classes later. There needs to have inner classes, the jar file that you want to replace. And the jar file, the whole concept here is that it can and should have probably been loaded in the memory from the beginning. But the important part is that you need to find a method or one of the classes inside this jar file that has not been run before. So, because what happens when you run a method in the URL class loader is that the class loader will not load all the classes directly. So if you have one class that hasn't been running before, that's the one that you can actually trigger. But what's interesting here is that if you don't have inner classes, it will have already loaded the existing one. So then you cannot replace it. This only works with inner classes on inside classes that you haven't run before. This is a very simple example, and this is what my demo code on GitHub will show you. Basically, everything except this part is happening on load. When you're loading the build and run, everything before this line will run already. The hello world.jar is loaded, all the method has been initiated, all the instances have been initiated, but if you replace the jar before the invoke, then you were able to actually run code. I made the public repository on GitHub basically showing this example. Happy to play around for you to play around with, and I look forward to see if maybe I was wrong here. Maybe this is like an obvious thing. I don't think it is. I hope it's not, and I do believe that there will be more places that you might find this on. Thank you so much. My name was Frans. I hope to see you again, and thank you so much for having me on this conference. Thank you. Bye.